Welcome to Bot Thoughts by AmtocSoft. I am Alex. The first time I watched an LLM agent move through a compromised box in a red team replay, what unsettled me was not the cleverness. It was the patience. The agent enumerated the environment, found the cloud metadata endpoint, pulled temporary credentials, and started listing S3 buckets. It did all of it in the flat, tireless cadence of something that never gets bored, never fat fingers a command, never pauses to look something up. There was no dramatic moment. No aha. Just quiet, methodical enumeration at a speed no human attacker would bother to sustain, because no human attacker would need to. This episode is about what that changes for defenders and what it does not change. For 2 decades, the limiting reagent in offensive security was skilled human time. Novel bug finding, exploit chain building, careful lateral movement through a network, that took an expert, and it took hours or days. Our defensive postures quietly assumed that scarcity. Detection thresholds, log retention windows, incident response timelines, all of them were calibrated to the cost of human attacker time. 3 things have changed. First, the speed of post-compromise. An agent can traverse from initial code execution to cloud credentials to data exfiltration in seconds, not hours. The window in which defenders can detect and interrupt the chain has compressed dramatically. Second, tirelessness over breadth. A human attacker prioritizes targets because they have finite attention. An agent tries everything within scope simultaneously or in rapid sequence, without fatigue, without distraction. The attack surface that a human would scan in 2 days, an agent covers in 2 minutes. Third, adaptation in the loop. When an agent hits a blocked path, that is not a dead end, it is information that gets fed back into the next decision. The agent logs the block, adjusts, and tries an adjacent approach. Human attackers do this too, but they have to read and process the error message. An agent has already decided and acted before a human would have finished reading the screen. What did not change? The techniques themselves. Credential theft from the cloud metadata service is ancient. Listing S3 buckets is ancient. Extracting SSH keys from a compromised host is ancient. What changed is the cost of executing the full chain competently. Defenses calibrated to human execution cost need to be recalibrated to machine execution cost. The documented cases are not theoretical anymore. In May of 2026, the first known zero-day 2-factor authentication bypass, developed with AI assistance, was used for mass exploitation. The Marimo vulnerability disclosure documented post-compromise movement, where an LLM agent extracted cloud credentials and SSH keys before human defenders identified the intrusion. We are in the period where AI-assisted attacks are moving from proof of concept to operational. To defend against an agent, you have to think like one. Let me walk the observe-decide-act loop of a post-compromise agent. The agent starts with initial access, a code execution primitive on a container, a web server process, a Lambda function. The first actions are always enumeration. What is the environment? What services are reachable? What identity am I running as? The single highest value link in the chain is the jump from code execution to valid cloud credentials. On AWS, that is the instance metadata service hop. HTTP get to 169.254.169.254/latest/metadata/em/security credentials. On GCP, it is the metadata server at 169.254.169.254/compute metadata/v1. Every major cloud provider has an equivalent. If that hop succeeds, the agent has temporary credentials with whatever permissions the workload's IAM role carries. From there, list the accessible storage buckets, enumerate secrets in the secrets manager, map the network, look for adjacent credentials, and begin staged exfiltration or lateral movement. Everything downstream of the IMDS hop depends on it succeeding. The credentials it returns define the blast radius of the compromise. What makes the agent's execution of this loop fundamentally different from a human attacker's is not cleverness. It is the absence of friction. No typos, no misread documentation, no pauses to think, No pattern fatigue from running the same enumeration steps on the 100th host. Error messages are useful feedback, not frustrating blockers. A 403 response tells the agent that the path is blocked, which implies there is something worth blocking. Defenders can look for the behavioral signature of the loop: enumeration velocity, systematic breadth, absence of interactive gaps, non-human error patterns. The signature is there. The question is whether your detection infrastructure is calibrated to see it. Layer 1 of the defensive posture is blast radius reduction. Your goal is to make it so that even if the agent executes the full chain, what it gets is nearly worthless. The highest leverage single control is an Iptable's rule on your containers that blocks outbound traffic to 169.254.169.254, the IMDS address. One rule: zero dependencies. This breaks the most common credential theft pivot at the network layer before any application code runs. If you are running on EKS, this is also achievable through network policy. If you are running on GCP or Azure, the equivalent metadata service addresses have the same control available. You cannot always block the metadata endpoint. Some workloads legitimately need it. For those, the control is credential scoping. IAM roles should carry time-bounded session tokens, resource-level ARNs rather than wildcards, and condition keys that restrict use to specific source IPs or VPC endpoints. A stolen token that is scoped to one S3 prefix and expires in 15 minutes is nearly worthless to an agent that needs broad enumeration to achieve its objective. Short time-to-live credentials are a timing attack against the attacker's automation. The agent needs to complete the full chain, exfiltrate, or pivot within the credential lifetime. A 15-minute window forces the agent to move faster, which makes its behavior more detectable. A 12-hour window gives it room to operate at a pace indistinguishable from routine service traffic. The last blast radius control worth calling out is rotation cadence. Rotating credentials before they matter, as a scheduled hygiene practice, means that any credentials the agent may have observed or cached from previous access are expired before they can be used. Credential rotation is pre-incident hygiene, not an incident response action. Layer 2 is behavioral detection. The agent has a signature in your logs if you know what to look for. Enumeration velocity is the first signal. A human AWS administrator makes a handful of CloudTrail calls per minute when they are doing something deliberate. A post-compromise agent trying to map the environment makes dozens per second. The absolute numbers will vary by environment, but the ratio between baseline and post-compromise is detectable. Systematic breadth is the second signal. A human accessing a storage bucket accesses the bucket they need. An agent enumerating storage lists every bucket in scope, then every prefix in each bucket, then the metadata for each object it finds. The breadth is systematic in a way that human access patterns are not. Absence of interactive gaps is the third signal. Human access to infrastructure has gaps, pauses while the user reads output, decides what to do next, looks something up. Agent access does not have those gaps. API calls arrive in a continuous stream with millisecond-level intervals between them. Non-human error patterns are the fourth signal. Human operators make typos, retry with corrected parameters, show inconsistent request formatting. Agents do not. Their API calls are structurally consistent, correctly formatted on the first attempt, and retry deterministically on failure. 3 specific detection rules worth building now. First, a CloudTrail alert for IMDS metadata endpoint access within 30 seconds of a new container reaching a running state. That access pattern is not routine service behavior. Second, an alert for more than 10 distinct list bucket API calls in under 60 seconds from a single IAM identity. Third, log enrichment on internal service calls to capture the user agent and forwarded for headers, and alert when user agent patterns deviate from your known service baselines. The key calibration insight: your existing anomaly detection baselines are built on human behavior. The agent's behavior pattern is not an outlier relative to human behavior, It is a categorically different behavior type. You need a second baseline for autonomous agent traffic to detect it reliably. Layer 3 is response posture. This is where most incident response playbooks need the most revision. The timing of a human intrusion and an agent intrusion are categorically different. A human attacker who has established initial access typically takes hours to days to achieve their objective. Your incident response process has time to convene, assess, and deliberate. An agent that has established initial access can exfiltrate in under a minute. Your response process does not have time to convene. This means the first defensive action, credential invalidation, needs to be at least partially automated. Detection triggers invalidation. You do not wait for a human to review the alert, assess confidence, and approve the action. That workflow takes 10 to 30 minutes in even the most efficient security teams. Against an agent that is moving at API call speed, that window is the entire intrusion. Prescript the agent-driven intrusion runbook separately from your standard intrusion runbook. The forensic artifacts are different. Structured API call logs rather than bash history, no clipboard contents, consistent request formatting across every action. These are signals that help you reconstruct the agent's decision path after the fact, but only if your IR team knows to look for them. The goal is not to be cleverer than the attacker's agent. The goal is to make the environment one where a clever agent cannot accomplish much. Block the IMDS hop so credentials are harder to reach. Scope the credentials so a stolen token has narrow utility. Set short TTLs so the timing window is tight. Detect the velocity signature early. Prescript the automated response so invalidation happens at detection speed, not human speed. The attacker's agent has patience. Your defenses should have structure. Full detection rules, IAM patterns, and the defensive playbook at blog 261. Long-form video V043. Shorts S166 and S167. Subscribe to Bot Thoughts. I am Alex, and I will see you next episode.